So I think you have seen me before in ClickHouse meetup. I talk about security. I do security in ClickHouse. Yeah, so I'm a pen tester / application / product security dude in ClickHouse. I work closely with the engineer to protect ClickHouse Cloud. And so today we're going to talk a bit about DeepSeek data breach, which you guys probably have seen it on the news. DeepSeek data breach was released, I think, about last month, and it was with the research team that identify a ClickHouse database that is open on the internet. And obviously, on the left-hand side, I outline some of the consequences of data breach for organizations: reputation damage, financial loss, and etc. So, you know, none of us want this happen to our organization, obviously. And so this is one of those rare moments that we actually get on top of Hacker News. You know, the sales team tries so hard, the marketing team tried so hard to advertise us on Hacker News, and we never get to the top page or stay this long. So it's actually quite amazing. But it's not for the best reason. And obviously, people were comparing us to Elasticsearch. You know, is it the era of exposed ClickHouse or exposed Elasticsearch era is gone? So it's definitely not the best look. And of course, you know, on Hacker News, everyone is pointing fingers. Who did this? There was questioning whether ClickHouse have sensible configuration by default. So let's go through what went wrong. Right. First, obviously, the developer at DeepSeek didn't really care about TLS or man-in-the-middle attack. So there was no TLS installed on the box, even though Let's Encrypt is technically free. And it was open to the internet. And I just want to highlight that, yes, open the internet database is not great. And, you know, as a security guy, and all the security framework would tell you, do not open your database on the internet, right? But again, here's an example of a bunch of open to the internet ClickHouse database that run a lot of demos that we have you know, built by our engineers. And you can actually have queries running directly against these instances with a username and have no password as well. But they're not breached, and you know, obviously they still up and running. This is actually an open challenge to all the security researchers, and we have a bug crowd program running. So if you find vulnerabilities in these ones and you can bypass some of the security control that we have in place, let us know. You get some money. We get to have a free bugs, and we get to fix them. But yes, so. You know, things have changed a lot. ClickHouse actually have very good HTTP API that you can query and you can run query against. So, you know, these days, database can be on the internet. It just needs to be secure. You can have IP filtering back to your API server. And of course, as a security guy, I would always say, you know, put the API server in front of it if you don't know what you're doing, right? And yes, there was no authentications for the DeepSeek's database. And so obviously they have default users with no password, and everything was out in the open. So some people say, well, why do you have a default user with no password? And also there was full access, no quota, no limit, and yeah, data has no encryption. So basically, it was just out there, right? And that's the end of this presentations. Nah, I'm just kidding. But yes, so for default users, the worst case scenario when you spin up a ClickHouse instance, whether you apt-get install, yum install, or Docker containers, if you don't put a password in, it would actually put a clause in your default users that says this user can only be accessed from localhost. So I'm just going to put it out there. The default configuration is okay and it is safe. You know, we did consider this to happen. So obviously DeepSeek would have jumped through hoops to actually get their instance to be open on the internet. And of course, our Alexei's CTO have commented on the Hacker News about this and clarify that we do indeed have proper preventions in place. Yep, and also giving out the example of Play, ADSB Expose, and those sort of demo projects that you can actually check out. And of course, they also have ClickHouse instance running straight on the internet with a user that you can access. So how did he do it? How did he expose this ClickHouse database on the internet and you know, it's not hacked or it's not get drop table or whatever? And that actually come down to the ClickHouse security inside the open source itself. I don't even need to sell the ClickHouse cloud today. All we talk about is just good old ClickHouse security inside open source. And all the features that you get access to by just deploying an open source ClickHouse. So we start with create users. Create users, it's just as simple as this, right? And you have choices of double SHA-1 password, SHA-256, and I think 2 years ago we introduced bcrypt. As you know, bcrypt is a slow hash, so it takes a longer time to actually brute force or crack it. And I think last year or the year before, we introduced SSH authentications. This is going to be fun for you developers who want to use your SSH key to access your ClickHouse instance, so you can authenticate with your SSH key. Mutual TLS is another way. We're actually using it right now in ClickHouse Cloud. Every time you hit that SQL console, you run a query, it actually generates a certificate, a client certificate for your users with a specific CN, and then it would authenticate your session to ClickHouse Cloud instance. And this certificate is short-lived, so you get off SQL console, this certificate will just time out eventually. And of course, you can even have two authentication schemes at the same time for the same users. So you can have a bcrypt hash and a SSH key if you choose to access with either of them. So more on create users. You can also do external authenticator, LDAP, Kerberos, HTTP authenticator. The HTTP authenticator is an interesting one because you can set this endpoint and then you try to access ClickHouse. It would then take that username and password and actually do like a HTTP request to your HTTP authenticator with your username and password in basic auth. And then if it's returned 200, then you are in. It's kind of an interesting way of doing it. But hey, it's there. So if you want to use it, you can try. Create user valid until. This is actually quite cool, and it came out I think last year or the year before as well, so it's quite recent. But the feature allow you to set an expiration date, and basically you can time out your authentication. So if you want like a short-lived credential for your developers, you can use this way to provide access. And then you also have a choice of using host IP, which, if you already have your ClickHouse instance on the internet, if you don't have IP filtering and you just have it over the internet, but then you have specific users, administrator users that you want to access from just certain IP addresses, like your home, your corporate network, then you can use this host IP clause to basically say, hey, this user can only be accessed from internal 10.1 range, or you can say it's from this specific internet IP address. And then this is quota. So a lot of our demo is running on the internet, right? And one of the risks is that that noisy neighbor risk, right? Or well, I guess like many people using the same apps, same demo, and then someone might just query it and then run a big query and basically cause a denial of service attack on all the other users. So in this case, you can set like, max row to read, max result row. The cool thing about this is also, for example, if you think about data leak preventions, right? So if someone have access to your database and they can run a query, dump the entire database, that's not going to be good. For example, if that user is something attached to a service account on a website, and then that meant to just return like 10 rows at a time back to the front end. But now the credential is compromised and say someone perform a dump on your database, you don't want that to happen. So in this case, you can set like, hey, I only want to return at max 100 rows. So if someone compromises that credentials, well, they can only extract 100 rows at a time. So you already slowed down the attackers at that point. And then another thing is read-only access. So you can set this specific read-only clause at the end of your create users that basically prohibit changing, updating to the data. So what that means is that even if someone accidentally grant insert drop to these users, these users still cannot drop or insert because it's read-only. And next we're going to go quickly into grants. I think this is pretty much common, like you've seen it in every database already, but you can grant and revoke access to specific tables. You can use wildcard to say, hey, I want user to not have access to all the system table with a prefix of queries underscore. And of course, you can assign multiple roles to the user accounts. And with grant options, then that user now have the ability to grant access to other users. Next is authorization with row policy. So we have granular row policy level access where you can define a row policy that says only user with a specific security tag, so only row with specific security tag can be returned to, say, that role, analytic roles. So in that case, if someone have analytic role and they try to query this table, well, they only see the data that have the security tag column set to analytic. And then this is a fun one as well. Someone had a fun idea of using it with Grafana. So Grafana talking to ClickHouse using like a service account in ClickHouse. And then this person add a row policy that says if the users in the if the user name in the user table match with the client HTTP header coming in from the HTTP API, then you show those rows. So now you basically filter out the result back to Grafana based on the X user header that's sent to ClickHouse. And the X user header is actually set by the IDP, so identity provider, that logging SSO into Grafana. So that's sort of an interesting way of using row policy that I found recently. So that's an example there where I use user Grafana on ClickHouse. I access the this ClickHouse instance on the HTTP endpoint. And then if I set X users to sign.tran at ClickHouse, I only see the row with ClickHouse. But if I set it to admin, I see all the other ones. This was for some capture the flag thing. And next is another topic about authorization, which is view security. This came out February last year. So previously, user need access to the underlying table in order to access view. Materialized view is like one of the most favorite thing in ClickHouse. But with the SQL security definer, we now can create a view And we can set a definer that says use this service payroll account, service account, to query the underlying table. What that means is that we're creating a view named employees here that have access to the name and department columns in payroll table. But whenever people query the employees table, it actually uses a permission from service underscore payroll account to access the payroll table. And that means that the users that using the employees view no longer need access to the payroll table itself. And so they don't see all the other columns in payroll table anymore. This is another example of SQL security definer, where you have a source table writing to a target table. And again, you just need a service account that have access to both source table and target table for insert and select. And then after that, you just need to insert data into source table from, say, an API users that doesn't have access to the target table. And probably the last topic is about encryption address. So again, with ClickHouse open source versions, you do have these encryptions. You can have, you can set up your virtual disk encryptions on your ClickHouse. It's pretty straightforward, and you back with Azure Blob Storage or S3 Blob Storage. And we have built-in encryption function as well. So in this case, you can see that you can run decryption here using DeepSeek's pretty cool model as a secret, and decrypt one of the row from secure.flag table and get back the values. At the top is when you query the data without the decryptions. And that's it. That's all for my talk.